Hello, welcome to this lesson in engineering mechanics. In this lesson, what we're going to do is work this problem in 3 dimensions. I know it looks really ugly and messy, but really, if you focus on it, it's not too bad. What we have is a circle of some kind. You can think of it as a ring, or marble, or some kind of spherical object. And it has a weight to it, so it's 900 newtons oriented down. And it's also acted upon by 4 additional forces here in red. And one of these forces goes in the x-axis and is 600 newtons, but that's the only other force we know about. All of these other forces we know the directions from the drawing, but we don't know how strong they are or how much force they are. In fact, that's what we're trying to find. What is F1, F2, and F3 in terms of newtons? That's what we're trying to find out. So ultimately we have an equilibrium equation here. We're saying this guy doesn't move. What are these forces? Now, the tricky thing about this is 2 things. First of all, the drawing is drawn in such a way to convey a lot of information. You're going to see this a lot. For instance, F sub 2 points purely along the negative x direction because you can see the dotted line coming out of it, which intersects this way. F1, if you look at the dotted lines here, it lies in the plane of y and z. There is no other components other than y and z, so it lies in this plane. The most complicated one extends in 3 dimensions. You can see F3, and the way it's drawn is you can see they'll talk about the triangle in a second, but it goes up and then a projection of this vector lies down into this plane. Now notice the triangles. We've seen the triangles all over the place in mechanics. They're just giving you the angle without really putting the angle on the paper. And I don't know why some books like to do that, to be honest with you, because in real life you're not going to see that, but they want you to kind of flex your trigonometry muscles a little bit. So when you see 3, 4, 5, it's basically giving you the angle of the vector. And so this guy is 3, 4, 5 giving you the angle that way, 3, 4, 5 is giving me the angle up, and then we have an angle related to the projection of this vector down into the xy plane. This is what this is supposed to represent. So our goal is to figure out a way to represent these 3 vectors in Cartesian form, and then we'll add them to the 2 known vectors, and then hopefully we have a system of equations we can solve for each of these unknowns. So we should end up with 3 answers, F1, F2, and F3. Now before we actually go on, I want to take a little aside for you. So I'll say recall here. Recall. Let's talk about this 3, 4, 5 thing a lot. I've kind of glossed over this a few times, but I want to kind of talk about it with you. If you have some force here, okay, and if I give you something like this, if I draw something like this and I say 3, 4, 5, I've told you several times that I'm implicitly giving you the angle in here. And what I mean by that is basically if you want to know which way F points, this information is encoded into these sides. What it's telling you is that if you go 3 units over and 4 units